Okay, I'm just Tony Fedor. I'm with Times Microwave. Just real quick background about myself. I've been with Times for just about 30 years now. Been in the wiring cable industry for about 38 years. Wide variety of different applications, but I'm just going to go over all the LMR cable, the connectors, the proper tools, connector installation. Go into some of the applications, a little bit of theory. I'm not going to get too crazy about the theory. It's just going to be more product related, as you can see by all the stuff on the table here. We'll talk a bit about lightning protection products out there for surge suppression, and talk about in-building DAS cables. I'll go into a little bit, do a little presentation on passive intermod and what passive intermod is. A lot of people hear the terminology passive intermod. I don't think they really know what it is. And just kind of go over some of the special cable designs and some of the applications at the end. So a little bit of the information and background on Times. Basically what we do is all coax cable. We do all flexible coax cable, connectors, tools, and lightning protection products. Times has been around for about 70 years. We're located in Wallingford, Connecticut, about 75 miles northeast of New York. We're a division of Amphenol Corp, and we have a facility we actually have 4 facilities. The main facility is in Wallingford. We have a facility in Shanghai, which does a lot of our commercial products, and then we have facilities in Mesa and West Palm Beach, Florida, which do more of the military assembly work. Just a quick mix of our business. We're 60%, probably about 60% military, which is everything from Mil C-17 coax cables to high-end military microwave interconnects for electronic warfare systems, electronic countermeasure, radar jamming, all kinds of high-end applications. So a lot of military avionics, big companies like Lockheed Martin, Northrop Grumman, Raytheon, L3, all the big guys. And we're one of the main integrators with all high-end military microwave interconnects for the F-35, which is the Joint Strike Fighter. The other 40% of our business is what we call commercial wireless segment of our business. It's everything. It's everything from in-building communications to mining to commercial offshore, commercial shipbuilding, two-way radio, public safety, cellular base stations, railroad applications, anything outside of the military we consider in the commercial wireless sector. And so there's a lot of different applications there. LMR is our kind of our flagship brand that we promote, and there's a lot of different versions of that, which I'll get into, like the water block, fire retardant, PVC versions, some of our plenum versions, and I'll kind of go over those as well. For the wireless markets, again, these are all just very basic, just the applications we supply to two-way radio, public safety, wireless LAN, wireless internet, PCS, cellular paging. There's a lot of in-building DAS work going on right now, amateur ham, just anywhere where there's an antenna to equipment that you need a low-loss interconnect, that's where we play in. So it's really so many different markets. We don't have one single market that we're in that's like the main market. It's really anywhere there's an antenna, anywhere there's equipment, you have to interconnect. So that's kind of where we're at. So there's a lot of different applications. And different applications, everything from cabinet jumpers, base station jumpers, antenna feeder runs, mobile antennas. We're doing a lot of work with cows and colts, cell on wheels and cell on light trucks. We have a product called T-Com, which is a very flexible, ruggedized cable that gives you excellent low loss, and we get good passive intermod values with it as well. But a wide range of applications, again, anywhere where you're connecting an antenna to equipment. I have about 3 slides here on some of the basics of coax, not too much theory, but just to understand. Basically, coax cable, you want to move energy from point A to point B with a minimal amount of loss. Basically, the lower the loss, the better the maximum power transfer from the antenna to the equipment. And also the trade-offs there are the size of the cable. Obviously, if you need lower loss, it's almost like a pipe. You're fighting a warehouse fire, you want to fight it with a big hose versus a little garden hose. So usually the lower the loss, the bigger the cable. With some of the foam core technology, we're able to actually lower the attenuation values in the same size cable, and I'll get into that in a little bit. Again, the attenuation, basically it's a measurement of efficiency of the cable. Larger the cable, the lower the loss, and the lower the loss, the higher the frequency. Loss in dB basically is our logarithmic equation. It's a power in versus power out. I don't want to get into a lot of formulas, but for every 3 dB of loss, you have you lose about half the power. So obviously attenuation is very critical in a lot of these applications. And cable loss is proportional to length, so if you have 1 dB per 100 feet, you'll have 2 dB per 200 feet, and so on. And it can go the other way. If you have 1 dB per 100 feet, if you have 50 feet, it's only a half a dB. So it's kind of a linear equation. And it's also, as your frequency increases, so does your attenuation. They just work together. VSWR, basically it's voltage standing wave ratio, or return loss. Basically, it's a measurement of how well a cable is made, or how well you put together an assembly with any mismatches. Obviously, you want to minimize your reflections in any RF path. I kind of equate to a lot of people who don't really understand what VSWR is. It's like, you have a sports car there, you have a nice flat highway for 5 miles straight, and you can open it up for 5 miles and let that car go as fast as it can. And then what VSWR is, you start putting speed bumps and potholes in the road. And that's kind of affects your RF performance going down that highway. That's kind of what VSWR really is. We try and minimize the amount of VSWR. We obviously would like a 1.0 to 1, which is perfect reflection, nothing reflected back. But in the processing of cables, things like that, you're always going to have reflection. You're always going to have half wavelengths that add up into a VSWR. So we just try and minimize that as much as possible. Cutoff frequency, basically what cutoff frequency is just related to the cable size. Typically the smaller the cable, the higher the cutoff frequency. So you could say like LMR 400 cable is just about a 16 gigahertz cutoff frequency. In general though, nobody's going to ever use LMR cable at 16 gig. We see most of the applications, people are going up. Typically it was up to 6 gig, now it's actually up to about 8 gig. A lot of people using it up at 8 gig, so get everything in between. The LMR 900 is nice because you have 6.9 dB, 6.9 gigahertz is your frequency cutoff. A lot of these cables are used for rooftop antennas at 5.8 gig that can run from the rooftop antenna into the equipment in the basement. So it's a good low loss cable, and it's below the frequency cutoff of the cable as well. Through this. So basically the cable design, LMR cable, other than the physical size of the cables, they're all a little bit, they're pretty much all the same in design. Obviously we have a range of cables, as you can see kind of over there, starting from LMR 100. We actually go up to an LMR 1700, which is actually, we don't have it on there, but it's equivalent to like 1.25 inch hardline cable or corrugated copper. So we have about a dozen different cable sizes, and basically they're all the same, other than the biggest change is the center conductor. On all the small size cables, which is basically LMR 100 to LMR 300, we have a solid center conductor, solid copper. On the mid-size cables, which is like LMR 400, LMR up to LMR 600, we have a copper-covered aluminum center conductor. And on the larger cables, like this is an LMR 900 cable, and we have a hollow copper tube. So LMR 900, 1200, and 1700 have a hollow copper tube. And the reason for that is basically due to skin effect, all your RF signal runs on the outer part of your inner conductor. So you don't care what's on the inside of the cable. You don't care if it's air in the case of a larger cable, or even copper-covered aluminum in the size of the mid-size cables, because all your signal runs on the outer part of your inner conductor. So you really don't care. And with the smaller size cables, the conductor is so small, there's no real weight savings or cost savings, so we just go with a solid copper. Then after that, everything's pretty much the same. We use a nitrogen gas injected foam core. We don't use chemical foams that absorb moisture over time and your attenuation increases. We use a nitrogen gas injection. We actually extract nitrogen out of the air in our manufacturing setup, and we expand the polyethylene and get it up to probably about 85, 86% velocity in there. So there's a lot of air inside the cable. On the surface, you can't tell. It's a very tough material. It's not very spongy, just because we have very close, tight cell structure in there, and that's just our whole foaming process. Then after that, we have a bonded aluminum mylar shield, which is 100% bonded around the cable, and a high coverage braid. And that's where all your RF path is. The RF path is really on your bonded shield, and then the braid is there for additional protection as well as connector attachment, because you need something good solid to attach to. And then we have various jackets. Our standard LMR is going to be straight polyethylene, which is a very UV stable, rugged material. But we have a lot of other versions, which I'll get into as well. So some of the general properties, standard LMR cables, 50 ohm. We do 75 ohm cables as well. Basically what we do with a 75 ohm cable, like in the case of like an LMR 600s, if we made a 75 ohm cable, we just use a smaller center conductor. And it worked out really well because the center conductor size we use on the 600 cable is the same center conductor for the LMR 400 cable. So it allowed us just to take a standard conductor, use it in, and get a 75 ohm LMR 600 cable. We keep our VSWR, again, those speed bumps in the road, we kind of minimize those the best we can. Shielding, generally you get better than 90 dB of shielding when you have the complete 100% bonded tape and high coverage braid. And then the temperature range is just the materials. Most of the materials we use are between -40 to a plus 185 Fahrenheit. That's just polyethylene, that's just the temperature range. We do have higher temperature versions as well, like with our plenum cables. So the basic benefits, again, of LMR cable, very flexible cable, very non-kinking, easy connector attachment. I'll do some quick connector attachment in a minute. And you have loss comparable to corrugated copper cable. So you're taking a very stiff cable with relying on a corrugated copper. With our bonded shield and tape, we have a much more flexible cable, yet you have very similar electrical performance. So again, LMR, basically just point out too, LMR is a registered trademark of Times. A lot of people reference it on their websites and say, hey, it's equal to or better than LMR, and they don't put the registered trademark. So it is a registered trademark of Times for the products that we do have. Again, very accepted. It's been around for probably about 27, 28 years now. I think the strength of what we have is we offer a wide variety of not only cable, but connectors and tools and all the support hardware to work as a package. And again, I'll go over some of those in a minute. I think that's one of the big advantages of the product. Very simple part numbering system. Basically, when you have an LMR 400 cable, you'll use a CST 400 strip tool. CST stands for cable strip tool. You'll use EZ400 connectors or TC400, whether it's a field installable or a solder center pin. And so we try and make it very simple. You just match up the numbers. I get asked sometimes, oh, can you use a CST 600 tool with a 400 cable? The answer is no. You have to match up the numbers because they're specific to each other. Broad range of products. Again, standard LMR. I'll kind of go through these. There's standard LMR. We have our DB cable. What we do with the DB cable is we take our standard LMR, and then where you see the braid over there, we actually run it through a inert water blocking material. It's actually a molten material that almost like a molassesy type of feel to it. And as we run it through the extruder, we actually wipe it down, and it squeezes the water blocking material into the braid there, and then we pressure extrude the jacket so that no water can get into the cable. So for applications where you have rooftop antennas, mountaintop sites, your marine environments, offshore oil rigs, a lot of times people like the DB cable because it can inhibit any water ingress into the cable if the cable jacket gets damaged. Also, the same connectors are used, nothing's different, it just leaves a slight tacky feel on the braid. But in any areas that, that you have high moisture environment, this is a perfect solution. Ultraflex cables, these are a little different. This is an Ultraflex cable. What we do different with the Ultraflex cable is instead of having a solid center conducter, we use a stranded center conductor. And then the outer jacket, instead of being polyethylene, which is more of a plasticky feel to it, we use what we call a TPR, or thermoplastic rubber jacket. Thermoplastic rubber tends to feel like almost like a rubber band type of a feel. But the thing is, you can get really, really tight bend radius on this. I mean, I'm going within one times the OD, really, really tight bend radius. It's just a very flexible cable. There's trade-offs with LMR Ultraflex. One of the main trade-offs is the loss is about 15% higher. And anytime you have a stranded center conductor versus a solid, you have an increase in attenuation. But on the other side, anytime you go to stranding, it's much more flexible. So there's trade-offs with everything. The reality is most people that are using an Ultraflex cable, they're very short runs. They don't care so much about attenuation. They just care about the flexibility. It could be rack systems or things like that. Another kind of a negative to the Ultraflex is you really have to use solder-on connectors for these. You really can't use the easy styles with the pin, because those 7 strands in there, you could bend one of those pins in or out and create a short. So it's a little trickier to work with the Ultraflex cables when it comes to connectors. So we generally recommend that you use a solder-on center pin for Ultraflex. The FR cables, basically what the FR cables is, we take our LMR cable and we change the jacket to a non-halogen, low-smoke polyolefin material. It's all UL listed, as riser rated, and we print every foot of cable with our UL file number. One of the things a lot of times people will say is, oh yeah, we meet this requirement or meet that requirement, whether it's a riser or a plenum, but they don't actually have an approval with UL or ETL. We actually have all our approvals, and you'll see on every one of our UL listed products, we'll always have our UL file number. So it'll say like type CMR. CM stands for Article 800 of the National Electric Code. R is for riser rated, and then it'll say UL file E-170516. So all that information is on the cable there. And it's important for installers to understand that when an inspector comes in to sign off on the job, they're going to look for a UL listed product or that it's been tested by a third party NRTL, which is a nationally recognized testing laboratory like UL or like ETL. So we carry full listings. PVC cables, we do a little bit on PVC, not too much. Most of it's switching over to non-halogen, low smoke, and the flame retardant side, but we do have some PVC cables specified in. And then actually should be LLPX is our latest series of cables, as you can see here. We originally had the orange jacketed LLPL cables, which was basically what our plenum cables are. We use an expanded PTFE tape wrap, and then we have the bonded shield and a high coverage braid, and then we use the highly filled low smoke generating PVC compound. We actually switched the compound to a fluoropolymer for a variety of reasons. Number one, it's just a much better performer in the UL Steiner tunnel test, which is a very severe, very tough test to meet. We just got better smoke characteristic numbers and flame performance by going to that. You also get a lot of other added benefits. You get higher power handling, higher temperature rating, better UV stability, because a lot of people will use these cables, even though they're supposed to be used inside enclosed buildings and air return handling spaces, people still connectorize up to the antenna and will run the cables across the roof. So the UV stability being better helps as well. Just doing a couple of quick comparisons from some small cables all the way up to some larger LMR sizes, and I think you'll start to see why the foam core technology and the bonded shield design lends itself to lower loss cables and how it compares to standard RGs and what the benefits are. our smallest size cable, which is LMR 100. And again, when you see the number designation, it's basically the outside diameter of the cable. So LMR 100 is a 0.100 diameter. LMR 400 is technically 0.405. LMR 600 is 0.59. It's basically the outside diameter of the cable is the number designation. So the LMR 100, comparing to RG 174 and 316, you can see it's got much lower loss, much better shielding. It's just a better cable. Most of your RG, like an RG 174 or 316, they can be single braid designs. You don't get as good of shielding characteristics. And you just don't have the loss characteristics. The RG 174 is a solid polyethylene design. The nice thing with the LMR 100 is it accepts standard RG 174 and 316 connectors, so you're able to just use the same connectors that you have. 195 and 200 versus RG 58. We actually started with LMR 200 first. The problem was the LMR 200 was basically a similar outside diameter to the RG 58, had much lower loss, much better shielding. The problem is a lot of people said, hey, I got 1,000 connectors that fit RG 58, they don't fit your LMR 200. So what we did is we backtracked and modified the center conductor and the core diameter very slightly so it accepted standard RG 58 connectors. And then we had the LMR 195, which is a direct replacement for RG 58, accepts RG 58 connectors. But we had a lot of people that spec'd in LMR 200 and they didn't want to change everything, so we left 200. But if you're looking for a direct replacement to RG 58, you want to go with LMR 195. Much lower loss, and again, you can see basically, your loss characteristics, much lower loss and much better shielding. So, again, this is comparing to RG 142, and again, just shows you the loss characters. Much lower price cable, but to be fair to RG 142, it's a fluoropolymer, it's a Teflon core, so it's a higher temperature product. But again, a lot of people will switch over. They don't need the temperature characteristics, so they'll go over to the 195 or the 200. I mean, you look at LMR 240 compared to RG8X. I mean, it's a no-brainer if you look at this. Why would you use RG8X? It's just, much lower loss, much better shielding, wide range of connectors available out there, easy attachment connectors. Just doesn't make any sense not to use LMR 240. LMR 400, versus an Airspace or RG8. When we first started, this was our first product that we had out there in the whole LMR range of products. A lot of people were using a product called Belden 9913. What Belden 9913 was a center conductor. They used a spiral air spacer and then a tube over the top, and then shields in the jacket. Problem is, through condensation, heat, cold, outdoor conditions, you take off connectors and water would literally pour out of the cable. So you had a lot of corrosion going on between the cable and connector interfaces. And then you would also have relying on that little spiral spacer to maintain 50 ohm impedance. Meanwhile, these cables are moving, blowing in the wind, they're being bent around, very unstable cables. So what we did is we replaced that spiral spacer with the expanded foamed polyethylene, which allowed us to have a very rugged design, eliminate a lot of the water ingress situation, and it was much better, much more stable as the cable was flexed out there. You didn't change impedance. There's a lot of benefits to going with the foam core technology there. So again, you can kind of see, comparing, like I said, Airspace, which is like a Belden 9913. Basically, it's it's a little lower loss, same kind of shielding, but you've eliminated all those issues with instability and water ingress and things like that. When you compare to LMR 400 compared to a similar size like an RG213 or an RG214, you just have much lower loss, much better shielding, wide selection of connectors as well. And you can kind of see here, I mean, you compare the losses. I mean, an RG213 is a single braid, an RG214 is a dual braid, and even with a dual braid, you'll get about 60 dB of shielding effectiveness, where we get 90 dB with the LMR 400. So it's just a much lower loss cable, and in situations where you're worried about weight or size, maybe you have really tight size constraints, I had some people who were looking, they needed the loss of an RG213 cable because they were running it through very tight openings in a wall. And we were able to get them to LMR 240 cable, which LMR 240 cable, even though it's about 40% smaller, since it's a foam core and low loss design, even though it's 40% smaller, we actually had the same attenuation values as a much bigger RG213 cable. So they were able to use a much smaller, lighter weight cable that gave them the same electrical performance. In addition, you had much better shielding. So the shielding was much better as they ran all these cables next to each other. That was another concern. They had much better shielding. So it was a totally better solution than an RG213 cable. Then LMR 600 versus like a 1/2 inch corrugated, that's probably where it matches up closest to. And you can see the LMR 600 from a loss perspective falls right in between the standard corrugated and versus the flexible corrugated, where they change the angles of the corrugations to give a little better flexibility. But it's right in between loss parameters, closer to the standard corrugated. It's just much more flexible, much easier to connectorize, and it yields an excellent jumper cable coming off of feeder lines. Then when you compare some of the feeder cables, you start to get the bigger cables. We tend to do a little bit less in that area. I think that market in general has declined quite a bit, as we've had a lot of the macro build out of these big corrugated cables. They're starting to be replaced with fiber and category cables, and you're starting to have a lot less of the macro build out. You're starting to get much more of the pico cells and smaller type setup, so it's much smaller cables. But we still compare very good comparisons compared to some of the hardline corrugated cables. So basically very similar loss, shielding effectiveness. Flexibility is pretty similar and very easy to connectorize as well. So it's just a comparison again of some of the losses versus some of the corrugated. You can see they're right there. So even on the largest size, I mean, you look at the LMR 1700 is basically the same loss as an 1.25 inch corrugated. So very similar. Well, again, we don't see as much on that side of the business. I think it's declined quite a bit. When it comes to connectors for the LMR cable, we have a wide range of connectors, wide range of interfaces, just everything you could imagine, ends, TNCs, UHS, reverse polarities, right angles, you name it. We have two different attachment methods. One's a crimp connector, which most people use. Then we also have the two-piece clamp connector, where you're actually wrenching it down, the two pieces, and capturing the braid shield in between it for your connector attachment. Our two different versions of like the crimp connector, we have our EZ, everything in our catalog you'll see will either say EZ or TC. Anything that's EZ means it has a self-captivated center pin, which means it slides, the center pin is on there, there's no soldering involved. Everything TC is a solder center pin. It means you have to actually solder the center pin. So like on Ultraflex cables, you have to solder on the center pins with a TC. It's personal choice what people want to do. Some people believe that soldering is much better than the EZ. The fact of the matter is the same performance. The big difference is with EZ style connectors, they're field installable and you get much more repeatable results. Whereas when you start to look at soldering, you can get a wide range of results. People could melt the core when they're soldering. They could push the pin in too far. There's a lot more things that can go wrong with solder versus an EZ style. And again, a lot of people, you got guys working out and they're in underground areas, they're in a mining application, they're alongside railroad tracks. These guys don't have a nice well-lit area with electrical outlets sitting right there for a hot soldering iron. So it's much more difficult for them to use those type of products. So we always recommend the EZ style connectors, just very repeatable, very easy to use. So we're talking about the connector attachment, might as well do one right here. Basically, with all the cables, and we'll attach an EZ style connector. We have our CCT cutting tool. First thing you always want to do is start with a nice clean cut. A lot of times people have a pair of dikes or cutters and it turns the the nice round core, it's almost like a football shape, which anytime you start to get away from a nice circular core to a football shape, you can start to have electrical issues. So one of the first things you always do is always recommend that people use, just cuts that off and gives you a nice clean cut. I know it's hard to see and everything, but it gives you a nice clean cut. Then we have the strip tools. You can see we have different strip tools for, LMR 195, 240, 300, 400, 500, 600. We have different color strip tools so that people don't confuse them one to the other. And so what I'm going to do is use our CST 400. CST stands for cable strip tool. We have a side one and a side two, and then we have a, see if I can read this here, crimp and a clamp connector. We can set, there's really 3 tools in one. We used to sell 3 separate tools. It's set to crimp because I'm going to put on a crimp connector, but you can loosen this up, slide this up, and lock it down to clamp, and then you have a deburring tool on the side. So we put 3 tools into one. We also came and put this hard kind of a cutting blade on here because our old tools used to kind of rip through, and it really wasn't the best for higher frequency performance. We saw that you need a clean cut on that core on a 90 degree to the center conductor to get good electrical performance, especially as you start to get up in the gigahertz range. And a lot of things are going up to 802.11a at 5.8 gig or 802.11b at 2.4 gig on a lot of the unlicensed bands. So things are going higher in frequency. So first thing we're doing, probably what I'll do is I'm going to pop on. Normally our connectors come with a shrink boot, and so you put the connector on, use a shrink boot. We've come up with these, what we call our WSB boots. They're weather seal boots. Very creative with our part numbers here. But weather seal boots, we have them for this is for the 400, this is for the 240, this is for the 600, just different on sizes. But we have this little, I'll pop this off. I know it's a little hard to see, but you put like a little dab of this rubber glide on here. The one that's open here, that might help. A little bit of the rubber glide on there. And it's just a non-toxic material, and it just dissipates real quick. And what this does is it helps you to slide on. There we go. Just want to slide that on. I should put another drop on there. But basically just sliding it on there. Just put another drop on. Okay. Just going to put a little more in there. It's really tight on there. Okay, there we go. So you're taking your CST 400 strip tool, and again, you got side one, you got this little latch in here. Again, a little hard to see, but just pop it in until it bottoms out. You can see the cables in there. You just keep a little pressure on the thumb wheel here. You just give it a couple of turns. Takes it right down to the center conductor. It's the exact length you need it. There's no measuring. Gives you a nice clean cut, 90 degrees to the center conductor. And you take the other side and you have a little deburring tool. And all you're doing with that deburring tool is you're just taking out the high edges on the tool. You're just taking out the high edges so that you round out. There's such a close tolerance on these beryllium copper spring fingers, you don't want to bend them in. Same side as the deburring tool. You just let the tool do the work. Again, a little hard to see, but you kind of see the jacket being stripped off right there. Just go till it turns freely, and there's your jacket. Then all you're doing is just fanning out the braid a little bit. And you take your connector here. Oh, I forgot something. Forgot to put on the back of the crimp ring. There we go. Pop on the crimp ring. And again, you got a self-captivated center pin in there, beryllium copper. Kind of give it a little push, and it's on there already. But what you want to do is you want to give it that one last push, and you can actually feel those beryllium copper spring fingers locking down onto the center conductor. Then you slide up your crimp ring. And now we have two different tools. We have our ratchet style tool, which is a little more expensive with dies. And then we have a less expensive tool, which is a non-ratchet style with already set dies in there already. So So just take the tool and you get up nice and close there. And basically you're just giving it a crimp. And now you have it, it's crimped. You're gonna get about 250 pounds of pull strength on there. You always want to crimp, and before I push the boot up, you always want to crimp as close to the connector body as possible. Now one of the things, there's only like 3 things you can really do wrong with these cables or putting connectors on. Number 1 is you don't push the connector on all the way. Some people see how it's on there, they're like, oh, it's on there. You have to literally push that connector. You'll actually feel, and you can almost hear those beryllium copper spring fingers opening up, grabbing that center conductor. So sometimes people don't push them up all the way, and I always tell people the easy way to tell is normally your braid ends up right up against the end of the connector body when it's pushed on all the way. If you have a big gap there, that means the connector's not pushed on all the way, you have to push it on. So that's an easy way to tell. Another thing is when you crimp, you want to crimp right next to the connector body. Now, a lot of people notice the back end of this crimp ring. Again, it's a little hard to see, but the back end of this crimp ring is uncrimped. So a lot of times what they do is they grab the crimper and they crimp it again in the back side of the connector. You don't want to do that. Because what you're doing is, and again, I can't show you because I crimped it already, but what you're doing is you're going to end up crimping the jacket and the core and everything down, and you crush the core. And what you've done is get back to the VSWR with a nice sports car going down a flat highway, you just put a big speed bump in the RF path, is really what happens. So 1 crimp right up against the connector body, and that's it. And the last thing a lot of people do is when they, which is not, you just gotta be careful, is when they use the deburr tool, I see people doing this. They're deburring, all the metal flakes are falling back into the cable. You wanna face it down. You want to have the cable, let everything, all the little flakes that you're deburring, let them push away from the interface. So really, there's not too many things you can do wrong there. So, and now the last thing is just to push it. I'm going to be able to do this once, so you have to kind of listen. And basically, when you slide this up, you'll actually hear it click on with these WSB boots. There you go. You can kind of hear it, and that locks in, gives you IP67 weather-tight seal, and that's it. You get excellent strain relief, easy connector attachment. There's not too many things you can do wrong. Again, if you start to look at soldering's a lot trickier. I'm just gonna flip over. Let me just hit this one last slide, and I'm gonna switch over to just talk about soldering real quick. Basically, we have all the other stuff as well: wrenches, strip tools, ground kits, hoisting grips, cold shrink, entry panels, snap-in hangers, everything that's all the other hardware as well. Let me just switch over real quick to, since we're talking about, just go with this one. From current side. I'm just going to talk about real quick on some of the soldering. And again, we kind of looked at what contributes to overall insertion loss, and there's, the materials and cables, the physical geometry, any of the mismatches in the cable, all this stuff leads to poor visual, poor attenuation, things like that. And one of the things in the assembly, and I'm not going to get too much, but again, kind of visual, again, you want to keep as perfect of a match, as minimal reflections in your cable and variations that can add up to a big spike. I'm not going to get too much into this. I'm just going to get into some of the mismatch loss. Obviously, we see a lot of people, they'll take our cable and they put on really bad connectors. They're connectors from wherever. They're just very poor performing connectors. And they have all kinds of VSWR problems, doesn't look good. And we always get the call, it's like, hey, I got your cable and it's bad cable. And it's not the cable, it's the connectors. We take the cable assembly back, we sweep the cable up to 6 gig. We see a lot of high VSWR, a lot of high grass on there. You can see it's the connectors. We know it's not even our connectors. We can tell the look of it. Cut off the connectors, we re-terminate, just like I did here with the connectors, and we sweep and everything drops back down. So everything in that RF path, from the connectors, the cables, and the attachment procedure has an effect on RF performance. If any of those areas is weak, that's what you're gonna see. It's like the old saying, you're joining a chain together with a paper clip and you pull the chain, it breaks. It's not the chain breaking, it's the paper clip that's holding it together. So everything in that RF path has a function and has to work together to give you excellent electrical performance. So I'm just gonna show a couple of quick comparisons of, and again, comparing a couple of different manufacturers, and we're gonna look at, this is a solder center pin, and why we like the easy style. A lot of times you need proper pin to core gap, and an ideal termination. You're in a nice lab, nice well lit, somebody who knows how to solder, puts the connectors on properly, you get pretty good attenuation and Viswar values. So now if you look at a simple situation where you take the solder, a perfect solder pin termination, you compare it to pushing the pin on too far, this is the ideal termination. This is just by pushing the red, just by pushing that pin in too far, which is minimal if you don't have proper pin spacing. So already you're degrading your Viswar and your attenuation performance just because you're pushing the pin in too far. If we take that good, poor, and very poor pin soldering, you can go from there to here's a guy who melted the core a little bit and created all kinds of other issues. You could see just destroying your RF path. That's why we still like the easy style connectors, because they're just repeatable, they're consistent. So just takes all the guesswork out. And then even in crimping, proper crimp, and then there's a bad crimp. Someone's crimped down a little further, they got the braid all hanging out and everything. And basically, that's what you get after a bad crimp. I mean, you're just destroying it. And then here's somebody that actually, double crimping. So when I was saying the back end of the back end here is not supposed to be crimped. Only that one crimp. So what they end up doing is they end up crimping that second when they go from there to there. So that's where you end up. And on the surface, I ask a lot of people, you got guys in the railroad, guys in utilities, like, well, how do you test your cables? Well, just pull it, connector doesn't come off. Well, this connector doesn't come off either. So, it's the RF path is the important thing. It's not just that the connector doesn't come off, you could still destroy the RF path. So it's just so you can, again, final comparison, you go from the blue line, which is a good termination, to where you can end up with all kinds of double crimps and all kinds. So you can see, on the surface, connectors look good, they don't pull off, hey, what's wrong? But from the RF perspective, it's horrible. I'm just gonna go over now some of the lightning protection products we actually supply. Little bit of brief history, a lot of people are familiar with Polyphaser. Polyphaser has been in the lightning protection business for a long time. We actually used to be sister companies with Polyphaser. Polyphaser in times were part of Smith Industries. Back about, probably about 12 or so years, 13 years ago, we were sold off from Smith Industries to GE, and then we were with GE for 2 years, and then we became part of Amphenol we've been part of Amphenol for just north of 10 years now. But we actually used to be sister companies with Polyphaser. So what happened is about 7-8 years ago, we decided, hey, we should be getting in the lightning protection business. It goes right in line with all of the protection for your RF cables. It's a very synergistic product. We have a lot of our reps who are familiar with lightning protection products. We also have the distribution channels that sell the lightning protection products. So what we did is we came up with our own line of lightning protection products called Times Protect. And I'll kind of go through all the different versions of the Times Protect, but we've done a lot of work in the lightning protection side. A lot of people still don't know that we supply lightning protection. They know it's for LMR cable, they understand, but they're like, oh, I didn't know you guys, they usually say, I didn't know you guys made Polyphasers. That's kind of what they say. We don't, call it what you want. We make our own version of a lightning protection product, and we think we have some advantages too. I'm not going to get into really deep into any technical stuff. We have guys. Ken Rand is one of the guys. He can get and dissect a lightning bolt into all kinds of formulas and everything. We're not going to talk about that right now. But basically, this is just a statistical lightning event from NASA. It's basically saying the lower part of the thundercloud is usually negatively charged, and you basically have an upward strike from differences of positives and negatives, and that's what your lightning strike really is. So how does this affect and fit in with all RF transmission and cellular base stations and and things like that. And again, I'm not going to go into too much detail, and there's one slide we'll get to in 2 slides from now that really explains why in general you need lightning protection. It's basically an 8-hour class in one slide. But basically you have a strike voltage distribution, you have a high peak 300 kV peak strike, and it comes down into your shelter, into your equipment, where all your equipment is, your radio equipment, things like that. And essentially what happens is, I'm gonna kind of get right to it, is most people will ground their coax cables. They use grounding kits. They try and use them every 75 feet on a tower. If it's not the tower shorter, they'll usually put one at the top, one at the bottom. And what happens is when you ground those, you strip the jacket, you put on a grounding kit, you take off about 3/4 of the total energy of a lightning strike. So if you have in this scenario here, it's showing a 100 killiamp strike, and basically about 3/4 of it gets taken away with the proper grounding of the shields. That leaves about 27 killiamps still on your cables. Now, if you were to just distribute these, in this case right here, we have 18 cables on here. If they were all the same size cables, it would all split evenly and basically be like 1.7 killiamp coming down on your coax cables, which again, the coax cables can handle that. So the question is, okay, well, if you have properly grounded shields, then why do you need lightning protection? And this is the simple slide that's probably the most important slide this is an 8-hour class in lightning protection, right to the point. What happens is the red line is showing you the coaxial cable shield. That's the current on the outer shield. And if you look at that axis along the bottom here, that's time. So when you start a lightning strike, and again, it's very fast, it's just a pulse. So you have a lot of this energy that's on the outer part of your shield, and then eventually is a delay before it gets to the center conductor or the center pin because of your dielectric constant of your material. Because you have a center conductor and you have a shield, you have foam polyethylene, there's a delay by the time that energy is on the shield and then on the center conductor. What happens with all lightning strikes, you want to rise and fall at the same potential so that there's no damaging current to go to your equipment. So you can see you have in the early parts right here, the early parts of your lightning strike, all your energy's on the shield and there's hardly anything on the center pin. So you have a big they're out of phase basically. And basically, again, you have 2 differences of potential, and that's what you don't want. And then what happens is, as time goes on, you have more energy that's actually on your center conductor and not on your shield. It's kind of flip-flopped. Not as severe, but you still see where those arrows are. Those are differences in potential both time. That's where you get all your damaging effects that go into your radio equipment. So really what lightning protectors do is they bring everything to equal potential so that they rise and fall in the same potential so you don't get any of those damaging currents. That's really that's 8 hours of theory and all kinds of other stuff going into one single slide. So by far and away, that's the one slide. If you ever want to remember anything, that's the one. So next one is the BTR. This is I'm just gonna pass this around. This is a very popular polyphaser product. ISBs, this is our BTR, this is an NFF and female. Basically, the real big advantages here, number one, when I pass it around, you'll feel the difference of the weight. We use a brass body with white phosphorus bronze coating versus aluminum. We laser etch all the information on the side here, so we don't use stickers that fall off, things like that. We elongate the ends for bulkhead mounting. This is a polyphase unit is a little shorter. We put an O-ring for bulkhead mounting for weatherization. The nice thing too is this unit will go from 20 megahertz to 1 gigahertz in one unit. One SKU covers an entire range of frequencies, whereas here you need a multiple different, because they're all different frequency versions. So, guys going up to do a UHF site up on a mountaintop, and he gets up there and he pulls this out, and all of a sudden he's got the wrong one. He goes back to the office and wastes another hour and finds out, oh, we're out of them, we got to order them. You could have one unit and cover all the frequencies. So, as you pass this around, you'll feel the difference in the units. And that's one of the big advantages of it is the electrical performance, the physical characteristics, as well as the mechanical characteristics. And most people say, okay, that's great, how much more expensive is it? We're actually slightly less expensive than the competitive product. And we knew we had to be aggressive price-wise to start to get people to think of us as more than just LMR cable.
Right.
So, and again, same designation. You have the lightning protector, the BTR, N female, female, N male protected side, and NMS is N male on surge side. So it just depends on the way it's being installed. The next one is the BTR W-N. It's basically the identical electrical performance, but this is an outdoor weather rated unit because it's very difficult to weatherproof those with all the sharp edges and squares. Just not a great, it's not meant to be an outdoor unit. What we do is everything's press fit here. There's no area for water to get in. So basically it's the same electrical performance in an outdoor unit. The same thing there. Next one is our HBX. And the HBX is really a high power design. Basically it's a 750 watt protector. This should be the HBR right here. So it's just this is an N female, N male, but basically it looks like this. It's really designed for like combiners, things like where you're looking for high power applications. It's a DC block design. Again, 750 watts, so it's a high power. Excellent electrical characteristics. If you look at your graphs for attenuation and VISWAR, the whole idea too is you want your attenuation and VISWAR to be minimal. You want to, when you put this in line with stuff, you don't even want to see it electrically. So we've done a lot of work to make sure electrically it's good from an attenuation and a VSWR standpoint. This is the HBX. This is a DIN series. Again, same type of thing, you know, DIN female, female. If you're on the, you want a male DIN on the protected side, it's just HBX, DMP, DALE, DIN male protected side. And HBX DMS is a DIN male on the surge side. So again, it just depends the way you're orienting the lightning protectors in there. STRL series. This is more from the cellular carriers. Excellent PIM performance. We test 100% test for passive intermod on this, and I'll talk about passive intermod a little later. Same type of thing, you know, DINs, N female, female, N male on the protected side or N male on the surge side. We first started with our STR series before we had the STRL, and the STR went from 800 meg up to 2.5 gig. Problem is with all the 700 megahertz public safety stuff, we didn't cover that frequency band. So we came up with the STRL series and we went from 680 up to 2.2 gig, and it covered the 700 meg public safety as well as the cellular frequency bands in there. So you cover everything with a high power lightning protector in there. And again, 100% fully tested for low passive intermod. The carriers are very big on minimizing passive intermod. We'll get into that again a little later on what that is and why it's important. And that's just with the DIN, just showing the DIN. Again, we show N connectors, you know, STRL, NFF, DFF. It's just the different interfaces. Everything's pretty much the same, you know, similar performance. STRH, again, it's you know, DC block, 700 meg, and we have a little extended frequency range up to 2.7 gig, kind of, you know, high performance, you know, 500 watt protector. Again, STRH DIN series, you're just changing the interfaces again. Kind of skimming through the top of this. And we're starting to see a lot of requirements for 4310s. There's a lot of the interfaces that we're seeing in the cellular market, so we kind of adjust our offerings depending on what we really see. So a lot of the, you know, a lot of the DINs, a lot of people are going to the 4310s or smaller, you know, smaller interfaces. Everything's getting compacted, you know, smaller and smaller and tighter, and you know, density is starting to become a very big issue. And WBX, this is a WBX series, and it looks kind of similar. This is actually a GPX, but it looks exactly the same. WBX is for WiMAX applications, for like, say like an AT&T. It goes from 2 to 6 gigahertz. And basically what you're doing is you're covering that frequency range, which is important, 2.4, 5.8, things like that. Again, broadband performance, multi-strike capability. Again, just depends on the the frequency you're at, the application. That's why there's so many products. Just everyone's a little bit different. Same type of part numbering. Just WBX is like the frequency range of the the WBX is our designation for the 2 to 6 gig. NFF and female, and MP is a male protected and also we keep it very consistent. Just the products change. Now we start to get into the DC pass design. This is basically an application where you want DC pass broadband protection. Basically, you can see kind of you have an antenna, you have your jumper, you'll have lightning protectors, and then you'll come into your shelter. So a GPX basically this product we go from 1 to 2 gigahertz. That's the frequency ranges for all GPS, and you want it for a DC pass because a lot of times you want to put some energy on the center pin. You need a DC pass to run equipment. So again, there's just different versions of it, different interfaces. But again, this is geared. The circuitry inside the protector is geared for 1 to 2 gigahertz, which is your typical GPS frequencies there. Again, kind of just skimming over the top. DC pass is you have your GTRN series, which is DC to 3 gig. Again, broadband performance, all the same kind of characteristics all the way through. Excellent low VISWAR, low attenuation, white bronze plated body over the phosphorus bronze center pin, just low insertion loss, low return loss. And then GTRD is just a DIN connector. So this is one right here. Just basically, again, just your interfaces are different. Whether it's a DIN or a DIN, it's you can kind of see the electrical performance there as well. This is an interesting one. I'm surprised we haven't really sold a lot more. And I think part of it is a lot of people just don't know about it. We've sold some of these to the OEMs that want to get some level of protection. It's not meant to replace like that sample that went around, your traditional. But what we did is we took our, we have our easy style connectors like I showed you earlier, the way the connectors go on. And this one, oh, I can't, you put the connector on. You put it on right. But basically, it goes on, the whole idea here is we integrated a connector and put a lightning protector so it goes on and you slide up the crimp ring the same way. So it's like, if people they want to put on a connector yet they want some level of lightning protection, they can use these LP. This is an 18, is a 400, we have them for the 195, we have them for some different size. This is a 400 obviously. But it's nice because it goes on just like the easy style connectors, use the same tools. You can slide up the crimp ring, crimp it, and you get a level of lightning protection on there. So some of the OEMs out there are using this because they want some level of protection on their equipment. They're like, hey, we're putting a connector on, we might as well get some level of protection. But I still think this is an interesting product. I think a lot of people just don't know we have it. So. And the last one is the GTV, again, broadband, fully weatherized body, again, multi-strike, bi-directional operation, DC pass, low insertion loss through a broad frequency range. And again, there's different levels of protection depending on what different applications are. This is just a SMA. So again, a lot of people have, the interfaces, they have SMAs, much smaller, higher frequency applications. So the ends are SMAs. And that's the last slide on that. I just skimmed over the top. I didn't get into a lot of real detail on the theory. I mean, literally, Ken Rand does a lot of our, if people really want that training, he can come in and just blow your heads off with theory and stuff. And I think just people have to just understand why you need lightning protection. Again, if you remember that one slide where you have that difference in potential between the shield and the center conductor, that's why you need lightning protection, because that's where all your damaging energy is going to go to your equipment if you don't bring that stuff to ground very quickly. So in essence, really what you want with a lightning protector, you want it when everything's normal, you want it to be almost invisible. Low VISWAR, low attenuation, it's like it's not even there. But it's an insurance policy when you do get a lightning strike and you start to have something that comes down your tower into your equipment. You want to have some way of diverting all that energy to ground. And I've seen some people, it's interesting, some people will actually, they'll have cable running and they'll put this in between, and this is just out there, not connected to anything. You still have to ground it. You have to provide a path where the energy can get to ground. And a lot of people just leave them out there. They think this little thing just absorbs all the energy. It just diverts the energy to ground very quickly. So you have to properly ground things, or else it doesn't work.
So that was the question I had. Some of these appear to be inline.
Yeah, most of them are inline.
And some of them you can see on the housing, there's a flange or a bracket. That's got to be connected to
You have to
a ground shunt.
Yeah.
To take
Otherwise, where's the energy going? Because all you're doing, what lightning protectors are doing is they're diverting energy. And you got to remember, a lightning strike is very fast rise time. I mean, it's just very fast. And all you're doing is that thing's got to turn on and turn off real quick. And all you're doing is it's energy coming down, and you got that train coming down. All someone puts the little lever, and the energy goes this way, not smashing into another train. That's really what it is.
Yeah.
In layman's terms, obviously a lot more involved depending on frequency and handling and how many watts it can handle and all kinds of things. But the whole key is you just want to divert the energy away from your sensitive electronic equipment. Otherwise, you're just going to blow everything out. So it's really just an insurance policy for your equipment.
So the Times Protect seem to be all geared towards, that's the ground shunt.
Yeah.
There are some that used to be gas.
Yeah, there's gas. We have some gas tubes. A lot of them are just filtering technology. It just depends on the design. It depends on the application. We actually, I believe, have both. I believe we have gas tube, and we also have a lot of the filtering technology. There's just different theories of That's where somebody like Ken Rang can get in and really get into the theory of every little component within there and what happens in fast rise time and pulse currents and all this other stuff.
Yeah, I was wondering if the gas versions are like, once it takes a strike, it's done.
They're all multi-strike. I mean, I think what happens is a lot of lightning strikes too. You can get damaging effects. It's not so much from a direct lightning strike. I mean, I actually had, not too long ago, I actually had one of my garage doors was blown out because of a lightning strike, and the lightning strike wasn't right at our house. It was a ways away, but it was just, you have fields of energy around there. I think any piece of equipment, if it gets a direct strike, is probably going to do some damage, but you're trying to minimize it. But I think the reality is there's a lot of lightning strikes on there where you're generating energy, and it doesn't have to be a direct strike. You still need that protection. So
yeah,
I mean, it's an insurance policy for your equipment. So, but yeah, they're all multi-strike. I mean, and again, that's why we have like the lightning protector tester so people can tell. And usually, if something gets really damaged, you'll see it in the Visuar sweep. You'll see something. It'll either be a short or an open or. Yeah, just depends on how bad it is.
Yep.
But they're all designed to be multi-strike type products. So that's it for the lightning protection. Again, it's just another product that goes in as a synergistic product with all these other the coax cable, the connectors. And again, we look at the complete path from your antenna to equipment, and anything in line there. That's what we're looking at. So it's a lightning protector, it's good quality connectors, it's good quality cable, and it's the way all the connectors and everything get attached as well. So everything in that path has to work together to give you good RF transmission. A quick little presentation here on what passive intermod is, how do you mitigate it, what causes it, why is there concerns for it, things like that. So just going to skim over this. I don't want to get too deep into passive intermod because you literally could spend an entire day talking about PIM. But I think a lot of people hear the word PIM, passive intermod, they don't really truly understand exactly what it is. So really what PIM is a mixing of two frequencies. And basically you see it a lot where you have a transmit and receive, and you're basically interacting with the RF path with non-ferrous materials, non-linear behavior, creating an unwanted, what they call third order intermod, an unwanted signal in outside the frequency band of interest, outside the transmit and receive. So again, PIM is a very big concern with the carriers. Obviously, if they're transmitting and receiving in a frequency band, a lot of times these frequency bands are adjacent to public safety bands. Last thing a carrier wants to do, whether it's Verizon, AT&T, T-Mobile, Sprint, last thing they want to do is to generate a third order intermod that falls into a public safety band and start to interfere with public safety. That's a no-no for the carriers. So there's a lot of interest on passive intermod. So basically, again, PIM occurs when two signals pass through a nonlinearity, and there's a lot of things that can cause that. And again, it generates a third order intermod. And I'll see by the next slide, I'll show you the intermod with the desired frequencies and things. Basically, again, mixing of two frequencies, and will generate a what they call third order intermod. And there's a third order intermod, which is your biggest concern, is because it's your strongest signal. Then it goes fifth and seventh, so it drops off into less of a concern regarding passive intermod. So again, if you have a desired transmit and receive frequency here, you have frequencies there, and what can happen is you can create some of that interference that can come out and fall into a third order intermod. So things that we consider a nonlinearity, or examples of ferrous materials, you don't want to use nickel and steel, materials like that. It's a no-no for passive intermod. Poor contact joints are very big. That's why, like, LMR cables are great cables for regular RF transmission, for regular applications. But if you're starting to look at very tight passive intermod specs, the way the connectors attach and the contacts, just not a great low PIM system, low PIM design between the connectors and the cables. So we have a whole series of cables that are for in-building DAS systems. And any loose metallic particles, both ferrous and non-ferrous, whether it's in the connectors, it's in the cable, anything that's loose in there, all these things can create PIM. You can also have issues with PIM that are external to your cable and connectors, and those are a little harder to detect, but all we can do from our end is to test every single assembly for passive intermod and make sure that we meet the specs. So when we look at a lot of testing, we talked earlier about attenuation and return loss. Obviously, these are all important parameters in RF transmission lines, and PIM is completely different. I mean, you need to know what, you want to have a low loss cable. You want to have minimum amount of reflections with VISWAR or structural return loss, and then passive intermod is just another requirement that's thrown in the RF path. So again, a lot of people have looked at VISWAR to be the standard of how good a cable is made, reflections, but you also, again, the PIM just adds that next level of requirements. So here's like an ideal infrastructure. Basically you have your regular signal, you come in, you're basically passing with no mismatch loss, you're minimized, you're going to have your attenuation loss due to all cables are going to have some attenuation, some loss encountered with it. But basically the losses are kept to a minimum. And basically in good impedance uniformity, you're transferring energy from point A to point B without minimal amount of loss. So now here's a non-ideal infrastructure, and again, you basically have some PIM issues, and you can see you have your first signals that are coming in, and then you look on the right-hand side, and you have what you're starting to create, which is passive intermod. It's all those interference issues. And again, you need to look at the passive intermod as a test to determine that. You're not going to see that type of stuff just looking at attenuation or looking at VISWAR. You're not going to see these unless you actually test for passive intermod. So again, you have a sweep test, measures the efficiency of the signal. PIM test measures the ability to propagate the signals without generating that third, fifth, and seventh order intermod. So there's a big difference there. And again, both tests are very important to the RF transmission. They all have their function. So kind of gets down to what causes PIM. There's a lot of things that can cause PIM. So obviously we talked about ferrous, non-ferrous materials, anything introducing distortion within the RF path, things like, loose, inconsistent metal contacts, not enough contact pressure, which is one reason why LMR cables are not great, because even though it's a very tight fit, it's not a perfect soldered 360 degrees around. Cold solder joints, burrs, any kind of loose materials, any of these things can create passive intermod. And when you look at a cell site, there's also a lot of other things within a cell site. You have, guy wires, steel towers. You got to look at your lightning protection products. That's why on our STRLs, wherever we went, like our STRLs, we 100% test for passive intermod, because everything in that path can add up into an issue. Again, installation, poorly torqued connectors, scratches, stress fractures. If you're cross-threading connectors, or you're using connectors that are really poor plating and have minimal plating thickness, it starts to flake off. All these things are going to lead to passive intermod. So again, testing for PIM will identify weaknesses in an RF interconnect that wouldn't be picked up by return loss or attenuation. And again, we 100% test every one of our finished assemblies for passive intermod. So the only way to guarantee performance of every assembly is you have to physically test every assembly. You can't just test one assembly and say, well, I think we did it the right way, and let the next 20 go through and test. Some end users and suppliers do that. We don't, and we actually test every single assembly. I'll go into some of the details of our products that we supply to the in-building DAS systems. So here's just a couple of examples that you see. Obviously, poor cable preparation, dirt, trash, all those things that are in the system that can lead to PIM. Here's another one, poor cable prep. You can see on the corrugated, you got big nicks there. You have some material up on the top right-hand side there that's adding any contaminants, any flakes, metal flakes is going to be an issue. Here's another one, just loose edges, burrs, all this type of stuff's going to show up when you test for passive intermod. You won't see this with Viswar, you're not going to see this with attenuation, but you will pick it up. Cable damage is pretty obvious. You got a big crack in the corrugation. And again, sometimes you could have multiple PIM sources. You could have two bad connectors in there. And really what you have to do is you have to address you're going to see the bigger problem first. You could correct that one and still have a smaller problem that's being picked up. So really you got to look at the bigger problem a lot of times will mask the smaller problem. So like I was saying, you got to address the bigger problems before you finish the first one. So, and also PIM sources can be external to the system too. So you can have perfect PIM cable assemblies that you install, excellent performance, and you could still have issues outside of the system. All we can do from a cable manufacturer is ensure that what you take out of the bag with fully tested values, and it's a plug and play, and you should feel pretty confident that it's an excellent PIM performing product. And again, we can't control what's outside of the system. One of the other things too, we test cables, we do all our PIM testing is a dynamic. There's both static and dynamic testing. Static is you'll lay it on a test bench, you'll run your whole PIM test, and then you'll take your reading. Usually you want to be better than 153 dBc or decibels below carrier. And then the other way is a dynamic, where we actually flex the cable. Some people will take a little ball peen hammer and just tap the connectors to make sure the solder joints are good, and it's 360 degrees. We actually flex the cable, the connectors and everything, so you know there's no PIM problems. That's more realistic. IEC 62037 is the standard test procedure for PIM measurements. And again, both static and dynamic, which we talked about. We tend to test both. We report the worst number, and in most cases, your worst number is your dynamic or flexing PIM. There's a little YouTube live test that just shows you how it's done as well. So again, PIM is not frequency dependent. You know, a lot of people want you to test at 900, a lot of people want you to test at 1800. It's really depending on what system that the carrier is operating on. That's typically the PIM values that they want it at, but we don't see any real difference between the PIM performance at the different frequencies. So, you know, quick summary, you know, PIM reduces, you know, site performance. Obviously, the biggest problem is if you start generating an unwanted third order intermod that falls into public safety bands or interfering with other carriers. I mean, that becomes a problem. And you know, in earlier days we had high power transmit and receive on cellular base stations. It was, you know, it was pretty obvious the PIM that would occur. But now, even in building, even though the power's a lot less, there's not much room. The noise floor is so much tighter that, you know, they just, there's more requirements for PIM. Everything's getting dense in enclosed areas, and there's multiple carriers in the same area, and it's just it's a big concern. So, so again, you're just looking at the quality of the parts, the quality of the design, the way the connectors are put on. You know, we do an induction soldering 360 degrees around. We have the ability to X-ray our cables, which a lot of end users don't have that ability. We can actually look and X-ray our equipment to see what the solder looks like, what the inside of that whole, you know, cable to connector interface looks like. So again, best connectors for PIM, I mean, 716 DINs, obviously, you know, big connectors, you know, like this, tend to be very good with PIM, but we're going to some 4.310s. Things are getting smaller, denser, and it's really just contact pressure and surface area. Tight ends are okay. You know, same thing with TNCs and SMAs, but they're very small. And bad are things like BNCs, SMBs, some of the real small connectors, the bayonet kind of things. There's just not enough contact pressure on there. Again, you just start to have passive intermod issues. Again, materials, you know, good materials are brass, you know, phosphorus bronze, things like that. Good platings are silver, white bronze, gold. Certainly, you know, you want to eliminate any of the ferrous content. So the choice of materials are very important as well. I'm going to switch over. This is before I talk about all of the low PIM jumpers that we supply. And I'll go through all these in a second. I'm going to flip back to another presentation real quick and just talk about the, let's go to this. Second. All right. Kind of flip in and go to the, talk about the products. So just you know, kind of take a step back now that we kind of understand that obviously PIM is a big issue, materials, the construction, the design, the testing, everything has to work together. We're going to kind of talk about why all this is happening. And basically, PIM is an issue because, you know, with all the smartphones coming on, the data demand, everything going on, there's just so much traffic, so much data, so many carriers in close proximity to each other that you just got to weigh all these things out. Over the 30 or so years I've been with Times, I mean, when we first started making, you know, the bigger LMR cables, there was a lot of big, you know, 1.25 1.5 corrugated cables. Everything was, the C word back then was all about coverage. It was put up a big cellular base station and cover highways, cover, you know, high populated areas, things like that. That C word is switched. It's all about capacity. It's all about data demand. Everybody's walking around with cell phones. They want data. They want to watch video. There's just tremendous demands for data. So the way this is done is you just have to start generating, you know, your picocells and microcells and just overlay of systems, and it's just all about capacity. We just need more infrastructure for this huge demand for data. And this kind of just shows, this tremendous growth, and if you took it out to 2019, it would probably be double of what that is. So it's just this tremendous hockey stick kind of growth in data demand. It's interesting, there's only 3 ways you can really address the data demand. One is to reuse the frequencies with software to make cellular systems more efficient. The other is to open up some frequency bands. And that'll address, the first will address about 10% of the total growth needed. The frequency bands will address another 10%. That leaves 80% of the total growth in this whole wireless demand is going to have to come from infrastructure. So it's going to be a lot more cable, connectors, lightning protection, boots, everything, you name it. So it's just, you just need to build more infrastructure to address this huge data demand. And again, being a big sports fan, I mean, you can kind of see this is pretty self-explanatory for the NCAA Final Fours. People aren't happy. I mean, if you watch any game on TV, you look down, everybody's on their phones. They're watching a replay. They're seeing where a guy went to college. What's this guy's stats? Let me replay that. Oh, we're all booing the official. Actually, you made the right call. You watched it 6 times over on slow-mo. And so there's just, when you go to any of these events now, it's more of an event. It's not just going to a game and watch it. People want to feel interactive and part of the whole thing and be able to get whatever information they want. So DAS systems, I'm not going to, this is, an eye chart here, but basically a distributed antenna system is just kind of explaining, better coverage, obviously outdoor highways, downtown subways, tunnels, university campuses, a lot of people, you have a huge data demand, and then indoor, same type of thing. And this is just kind of some basic information on DAS systems. So again, why is DAS needed? Obviously for indoor, if you're in an underground garage or an enclosed area, you're in a tunnel, you're in an elevator, RF signals don't propagate very well. So you need to bring that signal inside a building. What's even more problem is, you look at even outdoor, if you have a cellular base station around, a lot of these new LEED buildings, they have RF barriers on the windows to make them more efficient so RF signal can't penetrate. So they got to bring the RF to a donor antenna and bring it into the building and redistribute it through distributed antenna systems. So it's like, you got to get the signal into the building, and then you've got to properly. And again, you may have a floors where you don't need as much. In other areas, you might have a convention center where you need a lot more coverage. So it's not a simple layout. Every single DAS system is completely different. This is just kind of a quick overview of some of the typical DAS components. Like I was mentioning, you got a donor antenna, you're redistributing. I don't think there's any one single technology that's going to do everything. I know there's a lot of talk about fiber. Fiber is going to have its place. You're going to have leaky feeder, radiating cables that are going to have their place in underground garages and stairwells and other areas like that. And you're going to have just short jumper assemblies that are connecting off of your feeder lines to distributed antenna systems throughout the building. So it's going to be all these components. It's not going to be one technology. It's going to be a combination of all these technologies working together. And every building is going to be different. Some are going to have more shielding in areas, some are going to have less, some are going to be able to penetrate the windows with RF signal. You're not going to have to bring it to a donor. I mean, there's a lot of variables when you start to look at total coverage inside a building. So again, we kind of talked about PIM. I'm not going to go through all this again. It's obviously a concern. Kind of skip through a couple of these things and just kind of get back to the products. We kind of went through all this materials, platings, obviously nonlinear contacts, poor connector design, loose tolerances, and poor soldering. Again, just kind of all the stuff we talked about earlier about PIM, so I'm not going to go, both static and dynamic. So now we'll get kind of into the products. And basically when you look at PIM, we have cables and connectors, we have jumper assemblies, we have lightning protectors, which we kind of talked about, and we do a whole series of test leads, which I didn't even get into. I mean, things like these low PIM test leads. I mean, you're testing, again, big 7/16 DING connectors, a nice grip you can wrench down and get good proper torquing. So we do a whole series. There's a whole other segment of our products for test leads, our Silverline test leads, our flexible extra flex cables, We even go all the way up into 40 and 50 gigahertz with our new Clarity series, which is real high-end test leads for VNAs, test gears, things like that. We actually go all the way up to 110 gigahertz with test leads. And as we see 5G starting to push higher, we see a lot of higher frequency applications, and then we also see a lot of sub 6 gigahertz applications. So it's going to be both ends of the spectrum, and we have products for all of them. So it just depends on what we're looking at there. So we break them up into IDAS and ODAS. IDAS stands for Inside Distributed Antenna Systems, and ODAS is outside. So if you look at our offering here, our main two is the TFT and the SPPs are our main two products. SPP, we have a couple of different versions of our SPP cable. We actually have three versions. It's SPP, and I'll explain the designation in a second. It's SPP, SPF, and SPL. The first S stands for super flexible. The next P stands for low pin, and then the SPP is super flexible low pin plenum. Then our SPF is super flexible low pin flame retardant. And then our outdoor or polyethylene version is SPO, is super flexible low pin outdoor. And they're different materials. So our SPP jumper assemblies, again, we assemble these, we induction solder the connectors on here. We've come up with a whole system and test system to make sure we have very repeatable results. And then we put a marker band on the outside of every assembly. So every assembly is 100% tested. We put our attenuation, our VISWAR, and our passive intermod values on every assembly. So when this is taken out of a plastic bag ready to plug and play, you have a test data with all the information. It's also on the marker band on there as well. All of the cables, the SPPs, SPS, SPOs, we supply in 1/4 inch, which is what this is, 3/8 and 1/2 inch. Most of our assemblies are typically about 1 meter, and most of them are 1/4 inch because they're only short assemblies, so there's not a lot of loss in here. Most people are just hooking up to antennas up in the ceiling. Again, our cables are 100% tested for passive intermod, and they're also all UL listed. A lot of people will put the word plenum on a cable. We actually put our UL file number on every length of cable. And it's important that people know that, because just because people put the word plenum on a cable does not mean it's a listed product. The only way you can put a UL file number or an ETL file number is if you actually have a listing with them. And what's happening is it's building inspectors are coming in and looking up in the ceiling before they sign off, and they're saying they want to make sure that you have a UL listed product, because there's too much, I guess deception is the best word, of people saying, yeah, it's a plenum cable. It's made with plenum materials, but we don't actually have an approval. We've never tested it, but it's made the same way as XYZ company. So always look to make sure that it's a UL listed product. Very important. So again, kind of explaining the design here real quick. We have a center conductor, copper clad aluminum. We use an expanded PTFE tape, a microporous PTFE tape, very low loss, high temperature, high power handling, and also is excellent dielectric with a very good dissipation factor up into the higher frequencies, up to like 6 gigahertz. Then we have a corrugated copper, and then the outer jacket we use a fluoropolymer. In this case, this is an FEP outer jacket, so we need the fluoropolymer materials to meet the plenum test. The plenum test is a very severe flame and smoke test that's required by the National Electric Code. Any plenum cables that are specified, they have to meet, it's a very tough test. It's a forced air. You can't burn the cable more than 5 feet, and they have both peak and average smoke density numbers over a 20-minute test. Very difficult test to meet. You need good quality, flame retardant, low smoke producing designs to pass this test. Very difficult test. That's why a lot of people don't go out and go actually get the listing, because it costs a lot of money to get the listing. You have to pay for what they call FUS, or follow-up service agreements with UL, and they randomly test the cables. And every once in a while you'll get a failure. If you get oil on there, you get something that's run poorly, maybe not processed correctly. There's all different kind of things that can result in a failure. a lot of people out there, they're not gonna make that investment, but they're gonna call it a plenum cable when it isn't. Same thing, this is the same basic design, just a bigger cable and the 3/8 cable, and same thing with the 1/2-inch cable. Again, most of the cables we see are a 1/4 inch in size. We have a very simple part numbering system. We try and keep things very simple like we do with our LMR cable. The SPP, super flexible, low pin plenum. Then you pick out your cable size, whether it's 250, 375, or 500. You pick out your connectors, your length, and feeder meters. So in this case, this is like an SPP 250. It could be 4.3M, 4.3M for the 4.310s, and 1 meter for the length. So it's very straightforward. So you can just come up with any combination, different interfaces, different lengths. You can come up with really it's limitless combinations of assemblies. Another product we have where people are starting to look towards more flexible designs is our TFT and our TFT low frequency. Basically, we have a TFT 402 and a 401. Basically, we still use an expanded PTFE tape wrap. It's a tape wrap dielectric, and then we have a special braid design we use, and then the outer FEP jacket. Again, it's all UL listed product. It's all plenum rated, so it meets all the plenum, the tough plenum testing. And basically it just gives you a very, very flexible, you can bend tight like that, not affect passive intermod. A lot of people have used solder braid type designs. What happens is solder blade, you flex it a few times, it starts to crack, you get loose materials, and you create pin, and it starts to show up. This design is meant to be a very flexible design with excellent passive intermod performance. So you got your TFT, again, like I said, you have your silver-plated center conductor, expanded PTFE tape, we have a silver-plated flat shield, and then an FEP jacket. And same thing with the TFT 401. It's just different size cables. The smaller one is the TFT 402, and then the bigger cable, like 265 diameter, is the TFT 401. We also have the TFT LF, and what we do with the LF, we don't sell as much of that, but low frequency, all we do is we change from the silver plated braid to a tin copper braid. So it's a little less expensive, but it's a lower frequency. Typically, most people want the high frequency just because they want the silver and the high frequency. One of the things I didn't even mention, but we've also come up with these boots that were coming out. These are we call them WPBs. We're introducing a whole series of them, not only for the TFT cables, SPP, but also for some of the LMR cables. And these WPB boots are weather protection boots. They just slide up and go up over the connectors. If you want to, sweep the cables, you disconnect your antenna, you want to seal it again, you just slide it up. So we're starting to come up with different boots for different connectors as well. So we keep adding to the portfolio of products to make it as easy as possible for installers to install the cable. ODAS, outside DAS. Now here we're not concerned with the flame retardant performance. So we have things like the LMR, lightweight, actually it should be smooth wall. SPO, which is this cable right here. Right here. And what we do a little different with this cable, well first let me just touch on the smooth wall. This is a real niche product. What we do with the smooth wall design is it's basically like our LMR 600 kind of core, and we basically draw down an aluminum tube, like a giant semi-rigid cable. Very stiff cable, but if it's in a fixed installation, you could put connectors on out in the field installable connectors, which give you excellent pin performance. Very niche type application. It's not a flexible design, but we do sell some of it. These SPOs, again, super flexible, low pin outdoor. In this case, our core is not the expanded PTFE tape because you don't care about flame performance, so we use a foamed polyethylene, just like we foam on our LMR cable. The outer jacket is polyethylene. Again, you don't care about flame performance. It's not a UL listed product. There is no flame requirements for us because it's used in an outdoor application. Arenas, football stadiums, baseball stadiums, outdoor campus environments like we have here, things like that. where it's used outdoor, they don't care about a UL listing of the product. Same type of thing, we have a 1/4 inch, 3/8 inch, and 1/2 inch. In this case, this is very similar to what the last one, DIN connectors, SPO. It's a very simple part numbering system. So again, like I mentioned, copper-clad aluminum center conductor, a foamed polyethylene. Again, we use nitrogen gas injection foam, excellent low loss, 86% velocity, very tough material, yet very flexible. Corrugated copper, and then black polyethylene outer jacket. That's the 3/8 inch size, just a little larger, and then 1/2 inch. Same part numbering system, same smart part numbering system. Again, SPO. This could be like an SPO, DM, 1.0 M. It's probably 1 meter. I'm just guessing. It probably looks about 1 meter. Very simple part numbering system. Another product we have that we sell a lot to the cows and colts, sell on wheels, sell on light trucks. A lot of guys would do a lot of work with like AT&T and some of the others. We've done to work for Sprint. We did the Super Bowl where they bring in these trucks and they deploy as they're concerned, obviously with PIMs. So one of the things we've come up with with our T-COM cable is with our low PIM connectors, we're able to attach low PIM connectors onto the T-COM cable. And the T-COM cable is similar in design to the standard LMR. We use the same foam core, but in the LMR cable you have a bonded tape and a high coverage braid, whereas in the T-COM you have a flat silver and a round wire braid. And what happens is when you flex these cables, if you flex the LMR cable over a certain amount of flexes, you're going to start to get micro cracking of that bonded tape. And what happens is that affects your RF performance because that's your path for your RF. So with the T-COM cable, with that, you can kind of see that the flat silver braid on the right-hand side, it almost acts as a hinge as it gets flexed. It can withstand multiple flex applications a lot better. Doesn't mean that LMR cable can't be flexed, but if you're going to flex thousands and thousands of times, going up and down on these lever arms, things like that, you want something that's going to be a little more rugged than LMR cable. So T-COM's a perfect solution for that. So again, one of the customers, the carriers, integrators, the enterprise infrastructure, neutral host providers, facilities at large venues. Whether it's a football stadium or baseball stadium, or whether a university, or whether you have a convention center in Las Vegas, or wherever there's you need these low PIM jumpers, you're going to see more and more of these antenna systems. They're just going to be popping up everywhere. So basically, this is my last slide on this. Just, we keep levels of stock, as do our distributors. We have a stock check feature on our website. You can go up and pull up. You can put SPP 250, NM, 1 footer, and you can see what inventory is there, who has what. If it's something that's a special interface or design, we usually turn them over in 2 to 3 weeks or less. And we just try, sometimes you can go on there and they might have, you might be looking for 3-foot assemblies. We might have a bunch of 1 meters. It's perfectly good to use for that. Or sometimes maybe you have there's a 5-footer, you need a 3-footer or a meter. It doesn't matter, you can still use a 5-footer. The loss is so minimal, it's such a short length, it doesn't make a difference. So there usually is always available, assemblies out there. So that's it for a quick, real brief overview of the of all the low PIM DAS products, and we're always adding new stuff. Talk about this last section is very simple. Just going to look at a lot of applications. We talked a lot about LMR cables and special. We didn't even get into all the specialty products. We'll talk a couple here, but just all these different cables, designs, constructions, and what are some of the applications, and that's what this last section here is probably about 40 or 50 slides, and I'll go really fast through 15 seconds a slide, just talk about applications. This is actually an application we did for bundled LMR cable. Again, I didn't even, I forgot to bring the sample, but we actually bundled 9 LMR 400 cables under one bundle. And this was actually for China Mobile. They had to build out for the Olympics very quickly when it was in Beijing back 6 years ago, whatever, 8 years ago, whatever it was. And basically we bundled 9 coaxes under one bundle, so they only had to pull one bundle up to the antennas, to all the smart antennas, and it just, because you could see on the pictures, it made a very clean look to it. Cleaned up a lot of the multiple cables that were on there and put them into nice controlled bundles. And this China Mobile, we actually supplied over 700 kilometers of that cable, so it was quite a large job for us, as you can imagine. Ericsson, Sprint, and we're talking about some, again, flexible bundled harnesses. We did some LMR 240 and some LMR 400 bundled. Again, you can kind of see going up to the antennas. They were interconnecting multiple antennas up there. We did 20 trucks, 2 harnesses a truck, and these are just all, plug and play, they just hook it right up to the equipment and away they go. So all unique applications. Extenet Systems, this was actually, this install right here was for the Michigan Wolverines football stadium. They were very big on aesthetics. They didn't want anything, ground bus bars hanging out, so we put the grounding wire inside corrugated coaxes and bundled designs, and as you can see, all hooked up to there. And basically, this was all done for the Michigan football stadium. Nokia Siemens, again, bundled LMR. We put 4 bundles together, and we also did LMR 240, same type of thing, 20,000 sites, and they just utilized very quick interconnects. They eliminated a lot of cable runs and poles and just made things a lot tidier and a lot cleaner out there. Like I said, Cows and Colts, sell on wheels, sell on light trucks. We do a lot of T-Com cables for that. It's an excellent design. It was kind of interesting. I was at the IWC show last year. We ended up seeing one of the cow companies. They had a display there, and they had a corrugated cable up there, and it was all kinked up. So I took a nice picture of it and said, you don't want to do this. I think you want to be looking at the T-Com cables. So they switched over to the T-Com cables. Again, provides an excellent flexibility, low PIM, ruggedized design. So that's another application. We did, for NASCAR, we did the Sprint Nextel type. These were actually harnessed cable assemblies that went on the trucks. Kind of a unique application, again, all with T-Com 400 Ultraflex cables. We do a ton of assemblies for Cisco. And you can see, basically we replaced, as I mentioned earlier, the Belden 9913 because of moisture problems they had. We used the DB cable, which again helps with any ingress of water. And basically they were operating up to 6 gig with these type of jumpers. And we just supplied tens of thousands of 20 and 50 foot jumper assemblies. Again, antenna pigtails, they were looking for a unique application. They wanted the cable to be plenum rated, they wanted it to be low temperature, they wanted it to be UV stable. So we were able to identify a fluoropolymer material that gave us all these things, and we came up with a whole series of pigtail jumper assemblies for Cisco. A lot of emerging markets communicate, a lot of satellite applications. Again, we're using a lot of LMR 600 dB and a lot of the 75 ohm versions as well, because we see a lot of 75 ohm applications. Cobham, again, they a lot of field deployable satellite dishes. They utilized all the tools and the connectors. They didn't know the lengths of cables they were needed. Some of it they were running LMR 400, some of it was LMR 600. They were able to take the easy connectors, field install, and just move on and deploy these systems very quickly. Gator, another one, field deployable satellite dishes, same type of thing. LMR cables and X-series connectors made it very easy for attachment, connector attachment. Globecom, same thing, field deployable satellite dishes. Radio telescope application, this is one we had rotatable connectors on there, some special designs. We've done a ton of work in positive train control, all the PTC applications, which is a mandate that all Class 1 railroads and some of the other commuter rails now are going to have positive train control. They're obviously concerned with trains running into each other. It's never a good thing. And these are all 220 megahertz positive train. We've sold literally millions of feet of cable and 100,000 connectors into this market for sure. We did a company called True Position. We did all these E911 upgrades where they can triangulate and find out if you drive your car off the road and you need help, they can find out where you are just by your cell phone. And again, just all LMR 240, easy connectors, easy style QMA connectors, you know, whole host of different you know, LMR cables and connectors for that. Work with a company, Inter Wireless, in-building wireless coverage. Again, you know, wireless and in-building DAS and all that is really, it's a utility now. It's just like water and electric. People just expect coverage. That's just the way it is. You know, if you're gonna have a new apartment building or a new, you know, campus building here on this campus, if you expect that you're gonna have total 100% coverage. It's expected, just like you have water, just like you have electricity. GE, all the MRI systems, we supplied all these kits for LMR kits with easy style EIA connectors for these lower frequency, high power MRI systems. So they're all interconnected for GE Healthcare with LMR cables. Applied Material, semiconductor equipment, all the lower frequency, high power type cables, things like we see with like these type of design. We didn't even get into all those products. It's a whole nother market of high power cables that we supply to. Again, rugged field deployable applications. Again, TCOM is a perfect solution. We're just doing a lot of work with AT&T on these, like, again, cows and colts for emergency broadcasts, where these things have to be low pin and they're constantly flexed up and down, and they're using it all with the TCOM cable. Applied Technologies use a bunch of LMR 240 assemblies. These were to measure wind shear, and these are all, you know, matched phased array designs where they measured wind shear and things like that. Rockwell Collins, all the Silverline products. It's a whole other product line I didn't even go into as well. Just a huge, a whole nother line of products that we have, all kinds of test leads. Paul Tassini's done a tremendous job with running with that entire program. It just continues to come up with new designs and new products. The latest is our Clarity series, competing with Gore on high frequency, 50 gig, better electrical performance, ruggedized at a fraction of the cost. So we're making some good inroads there. Radiating cables, another product line I didn't even go into. Our NewTrack and our T-Rad leaky feeder radiating cables. We probably have 500,000 feet of 1.25 inch radiating cable inside the New York City Transit for police radio systems. We've done big upgrades within the St. Petersburg Metro for multiple service applications where they have cellular and they have emergency broadcast. We supply a lot of cable out to St. Petersburg, Russia, out for that application. Path tunnels down in lower Manhattan, when they were doing a lot of the work, they used the T-Rad 600 leaky feeder cable as a very lightweight, low-cost solution to interconnect with all these bidirectional amplifiers to bring RF coverage for the workers for safety reasons. So that we provided a ton of cable to that. London Underground, we probably have well north of 1 million feet of flame retardant, LUL approved, all low smoke, non-halogen flame retardant designs. In addition, we have our 7/8 inch radiating cable in there. That's quite a bit. We probably have about 250,000 feet in there just in London Underground. Chief Joseph Dam, again, we use T-Rad 600 and T-Rad 900 cable. It's one of the largest hydroelectric dams in the country. This one's up in the state of Washington, eastern part of Washington. And they controlled all the corridors and all the monitoring within this dam and all the enclosed areas where the point source antennas didn't make a lot of sense. Security applications, we run our T-Rad 600 dB cable where they actually bury the cable in the ground and they pump signals, and there's 2 rings. And when somebody walks across those 2 rings, you change the capacitance field, and there's all software to calculate where they breached the security. So applications like prisons and high security areas, military installations, anywhere where you want to control the flow of people coming in, you can't see this, but this thing is monitoring security and perimeter detection. A lot of SCADA systems for irrigation. We see on a lot of our point of sale reports for our industry, you see a lot of unique customers. You'll see all these agricultural customers, and what they're doing is a lot of them are measuring the soil content. They have little antennas, and the antennas tell you when the crops need to be watered. So they save a ton of money and be super efficient with water, and they only water when the crops actually need it. So there's all kinds of very interesting requirements. Nomad Digital, this is a UK company. Again, we do a lot of rail cars where we use leaky feeder cables so people can use cell phones and they can have coverage inside, Wi-Fi coverage inside carriages on trains. Caterpillar, we come up with special designs for a Caterpillar for GPS. Everything that's done on these roads now is by GPS. It's, you know, the coordinates, everything's just, they put them on the blades, and we've come up with GPS designs. We've also, you know, come up with designs like this with our coiled cables, or as one of our guys calls it, a curly cable, but coil cables. This particular one is a coax that goes on a cab of a truck and to an 18-wheeler, and it goes to the video in the back so they can monitor everything, and it's just a flexible cord, coax. So we've come up with things like this, which we're starting to introduce now. Did a lot of 75 ohm, a lot of Gulf of Mexico oil platforms. Also did specialty designs for like the Hibernia oil platform. We supplied a ton of cable on that. It's one of the largest platforms off the coast of Newfoundland. Did a lot of Exer ruggedized cross-linked polyethylenes, had to meet all kinds of fluid resistance. So we're able to take all the materials and all the strengths we have and come up with different products. This is the one I was just talking about right here. Mining applications, all of our LMR-FR cables are also MSHA approved. MSHA stands for Mining and Safety Health Administration. It's a requirement that anything that's used in a mine has a certification, so all of our LMR-FR cables are all MSHA approved. So we've supplied a lot of cable for telemetry, SCADA, comm systems underground. Doing a lot with the yacht market and pleasure craft, things like that. A lot of work being done on 75 ohm FR cables for yacht applications, a lot of commercial offshore applications as well. We also do a whole separate section on our military side. We have all mil-spec approvals for cross-linked M17 shipboard cables for Navy vessels, for Newport News and Bath Iron Works, Electric Boat, Ingalls Shipbuilding, all the big shipbuilders. Do a lot of work with Trimble, GPS, again, same type of thing, highway construction, surveying, asset tracking, all that kind of stuff. Company Pinpoint, we used a lot of assemblies, plenum assemblies, so they can monitor. A lot of them are in hospital applications as they monitor, you know, drugs going around the building and stuff being delivered. They want to make sure that this stuff's not being taken to where it's not supposed to be. So everything's monitored with RFID tags in the carts, and everything's going in every direction. And Ritsu, we OEM a lot of our tough grip assemblies. If you ever see the Site Masters, it's all of our cables that are in there, and there's a ruggedized tough grip handle so you can wrench down and do your testing. So we do a lot of work with Anritsu on their Site Masters. American Tower, a lot of the DAS infrastructure, again, a lot of these neutral host providers. We supply a ton of, like I talked about, the SPP and the TFT assemblies, just a ton of different assemblies. Crown Castle, same thing, DAS infrastructure, you know, supply. Some of these should be a lot higher numbers now because, but this just gives you an idea of some of the different customers that we work with. Again, Sprint, that was actually for the Super Bowl. That was a Sprint LTE cow, and some of the things we did for, like I said, for the Super Bowl, where they're, you know, with these cows and colts, they bring them in where they don't have the infrastructure, and then all of a sudden they get a ton of people in, whether it's Olympics or whether it's, you know, they have a hurricane or a tornado and it takes down cell sites. You need to drive these trucks in, pop them up, and create capacity. This is another Sprint. This is showing our TCOM cable with our 80-foot low loss, low PIM designs. Thales, this is another interesting one we had. That's actually me right there talking to all these guys down. This is in the Yonkers, New York facility, and what was happening is they had these rail cars, and I'll put this picture. They had all these rail cars. That's a bomber rail car, and every time the train would go around a turn, the wheel set and the carriage would move, and the cables essentially would face a torquing like this. Not so much that, but like just a torquing. What was happening is the cables were actually breaking after maybe about 1,500 of these flexes. Well, they figured out that was less than a month downtime, and then These things ended up back here in the rail to be replaced. And they were literally taking cars out of service every 4 to 5 weeks, replacing these assemblies, and it got to be a major problem. Obviously downtime, they don't have enough cars. So what we did is we came up with a design, which is this. Let me just go back, but we came up with a design that went from about 1,500 of these flexes to over 300,000 flexes. So that came out to about a 30-year service life of the cars with the amount of flexes. And we built our own test chamber to simulate cold to heat. We flexed these, 16 hours of heat, and then flexed at 8 hours of cold, and we just kept flexing them. We went to like I said, 300,000 flexes in the new design. So we have a capability of looking at a problem and taking not only just what is our everyday products, but taking all the components we have and coming up with unique designs. So that's all the Thales. TransGuard, again, RFID. We're starting to do a lot of smart. We're seeing a lot of opportunities in ITS, electronic tolling. You look at companies like Capsch, they use a ton of our LMR cables for LMR 400 for all their toll reading equipment. There's just so many applications out there. Worked with this company down in Atlanta. Basically, they were tool management through RFID. And what they would do is they would asset tracking the tools. You're in a Boeing facility, you're in an facility, they have high-priced tools, and who's got it? And they can locate the tools and know where these tools are if they're not in the proper bin. We also worked with, speaking of Boeing, we worked with our TRAD leaky feeder cable for a special application where they were moving this real high-end, high-cost material, proprietary material, and it had to come out of a freezer and go from place to place. And there's only working life of about under an hour, and they had to know exactly where this material is, otherwise it was trash, it was no good. And it was a very, very expensive material. We were able to use asset tracking to use the cables to monitor where all these materials were in the plant. Mojix, again, oil and gas extraction, a lot of the shipyards, again, a lot of RFID. We're seeing a lot of RFID applications out there. Mobility, work with those guys on a lot of the Wi-Fi and small cell technology. We actually were approached by them. This isn't even our cable, this was another manufacturer's cable, but the other manufacturer didn't have proper low pin connectors, so we designed a whole series of low pin connectors for them. It wasn't even our cable, but we worked with them to get them out of a jam. So we have the ability to do those kind of things as well. Siemens, a lot of pharmaceutical research applications, again, lower frequency, just real high-end type applications. You got cryogenic type applications like Fermilab and some of the national labs. We have all kinds of requirements for high radiation, like 100 megarad type applications, as well as high flexing, things like that, and huge temperature extremes and all kinds of things. And we've come up with all kinds of materials to meet the requirements. So very, very interesting. Siemens Transportation, again, is another one that we do a lot, not only on cables, but also a lot of our lightning protection products going in there. And this is the last one, like Komatsu, again, GPS. A lot of these trucks are autonomous now, and everything's running by GPS, and there's no one driving these things, and they're just hauling around with mining applications and trucking applications. So they used a lot of our FRPUR DB cables because they were used outdoors and then in enclosed areas too, so they wanted it to be flame retardant and non-halogen, low smoke as well. So just a quick spattering of all kinds of interesting applications, and that's just on the commercial wireless side. I mean, we have a whole, 2/3 of our business is high-end military microwave, and that's a lot sexier than this stuff. When you start throwing up F-35s and F-16s and radar jamming and phased array radar systems and electronic warfare systems, it gets very exciting, but this is about as exciting as you can make coax right here. So that's it. That's it.
Thank you, sir.
All right.